In this question, we are given a table and we have to fill up the blanks. We are also given that A is the first term, D is the common difference, and AN is the nth term of the AP. So, beginning with the first part, we are given that A is equal to 7, D is equal to 3, and N is equal to 8. We have to find the nth term. Now we know that the nth term of an AP is given by A plus N minus 1 into D. Now substituting the value of A and D and N, here we have 7 plus 8 minus 1 into 3. So this is equal to 7 plus 7 into 3 is 21, which is equal to 28. Therefore, the nth term here is 28. Now, let us proceed on with the second part. In the second part, we are given A is equal to minus 18, N is equal to 10, and the nth term is equal to 0. We have to find the common difference D. Now, the nth term is equal to 0 implies that A plus N minus 1 into D is equal to 0. On substituting the values, this further implies that minus 18 plus N is 10 minus 1 into D is equal to 0. This implies that 90 is equal to 18, which further implies that D is equal to 18 divided by 9, which is equal to 2. Hence, the value of D is 2. Now let's proceed on to the third part. In the third part, we are given the value of D, which is minus 3, value of N, which is 18, and the nth term, which is minus 5. We have to find the value of A. Now we are given that the nth term is equal to minus 5. This implies that A plus N minus 1 into D is equal to minus 5. Now let us substitute the value of Dn. This implies A plus N is 18, so 18 minus 1 is 17 into D, which is minus 3. This is equal to minus 5. This implies A is equal to minus 5 plus 51, which is equal to 46. Thus, here we have 46. Let's now proceed on to the fourth part. Here we are given the value of A, which is minus 18.9, the value of D, which is 2.5, and the nth term, which is 3.6. We have to find the value of N. Now, the nth term is given to us, which is 3.6. This implies that A plus N minus 1 into D is equal to 3.6. Now let us substitute the value of A and D to get the value of N. The value of A is minus 18.9 plus N minus 1 into D is 2.5 is equal to 3.6. This implies that N minus 1 into 2.5 is equal to 3.6 plus 18.9, which is equal to 22.5. This further implies that N minus 1 is equal to 22.5 divided by 2.5, and this is equal to 9. Now This further implies that n is equal to 9 plus 1, which is equal to 10. Therefore, the value of n is 10. Now let us proceed on to the last part. Here we are given the value of a, which is 3.5, d, which is 0, n, which is 105. We have to find the nth term. Now we know that the nth term is given by a plus n minus 1 into d. Substituting the value of a, d and n in this equation, we will find the value of an as we did in the first part. So here we have 3.5 plus n minus 1 into d is 0. So this implies 3.5 plus 0 is equal to 3.5. Therefore, the nth term is 3.5. This completes the solution. In this question, we have to find the correct choice of the 30th term of the given AP. Here we are given 4 options and we have to find the 30th term of this given AP whose terms are 10, 7, 4 and so on. Let's begin with the solution. And let A and D denote the first term and the common difference of the given AP. This implies that A is equal to 10 and D, which is the common difference between any two consecutive terms, is given by 7 minus 10, which is equal to minus 3. Now we know that the nth term of an AP is given by A plus n minus 1 into D. So this implies 30th term is given by A plus 30 minus 1 into D. Let's now substitute the values of A and D in this equation to get the 30th term of the given AP. So A is 10 plus 30 minus 1 into D, which is the common difference, is minus 3. So this is further equal to 10 plus 29 into minus 3. Simplifying it further, we have 10. 29 into 3 is 87 and plus into minus is minus, so minus 87. This is equal to minus 77. Therefore, the 30th term of the given AP is minus 77 and here minus 77 is the third option. Hence, our answer is C is the correct option. So, this completes the solution. In this question, we have to find the correct choice of the 11th term for the given AP. Here we are given 4 options. From these 4 options, we have to find the 11th term of the AP whose terms are minus 3, minus half, 2 and so on. Let's begin with the solution. The given AP is minus 3, minus half, 2 and so on. Let A and D denote the first term and the common difference of the given AP respectively. This implies A is equal to minus 3 and D can be obtained by subtracting any term from its succeeding term, that is the term which immediately follows it. This implies minus half minus of minus 3. I am simplifying it, taking 2 as the denominator. We have minus 1 plus 6 in the numerator, and this gives, on simplification, 5 upon 2. We know that the nth term of an AP is given by A plus n minus 1 into D. This implies the 11th term is given by A plus 11 minus 1 into D. Now substituting the values of A and D, we have A is minus 3 plus 10 into D is 5 upon 2. On simplification, we have minus 3 plus 2 5s are 10. So we have plus 25, which is equal to 22. This implies the 11th term of the given AP is 22, which is the second option. Hence, our answer is B is the correct option. So, this completes the solution. In the following AP, we have to find the missing term. Let's begin with the solution. The given AP is 2, blank and 26. We have to find the second term of the given AP. For the given AP, let A and D denote the first term and the common difference respectively. This implies that the nth term is given by A plus n minus 1 into D. For the given AP, we have the first term A is equal to 2 and the third term is equal to 26. Third term is 26 implies A plus 3 minus 1 into D is equal to 26. Let's now substitute the value of A to get the value of D. Now here A is equal to 2 plus 3 minus 1 is 2 into D is equal to 26. This implies 2D is equal to 24, which further implies that D is equal to 12. Now we know that each term of an AP is obtained by adding a fixed number to the preceding term. This implies that the second term is given by A plus 12 and A is 2 plus 12. This implies the second term is 14. This implies the second term of the given AP is 14. Thus, the missing number in the box is 14, and this completes the solution. In this question, we are given an AP whose first and third term is missing, we have to find the missing terms. We are given the second term and the fourth term. First, let us denote A and D by the first term and the common difference respectively. Now we know that the nth term of an AP is given by A plus n minus 1 into D. And here we are given that the second term is 13 and the fourth term is 3. Therefore, we have A plus 2 minus 1 into D is equal to 13 and A plus 4 minus 1 into D is equal to 3. This further implies that A plus D is equal to 13, denoting this by equation number 1, and A plus 3D is equal to 3, denoting this by equation number 2. Now, from equation 1 and 2 we have, first writing the second equation, which is A plus 3D is equal to 3, and then writing the first equation. Now, let us subtract equation 1 from equation 2. We have 2D is equal to minus 10, This implies that D is equal to minus 10 divided by 2, which is equal to minus 5. Now, substituting D is equal to minus 5 in equation number 1, which is A plus D is equal to 13. So we have A plus minus 5 is equal to 13, which implies that A is equal to 13 plus 5, which is equal to 18. Hence, A is equal to 18, and this is the first term. So here we have the first term, 18, and now let us find the third term. Third term of an AP is given by A plus 3 minus 1 into D. Now A, which is the first term, is 18, plus 3 minus 1 is 2, multiplied by D is minus 5. So we have 18, 2 into minus 5 is minus 10, so we have 18 minus 10, and this is equal to 8. Hence the third term is 8. Thus our answer is, first term A is 8, and the third term is, the first term is 18 and the third term is 8. This completes the solution. In the following AP, we have to find the missing terms in the boxes, and here the second term and the third term are missing. And the first term is given to us as 5. Let the first term, denoting it by A, is 5, and let D be the common difference of the given AP. Also, we are given the fourth term, which is equal to 9, then 1 upon 2, and this is equal to 19 upon 2. Now, the fourth term of the AP is A plus 4 minus 1 into D. Since The nth term of an AP is defined as A plus n minus 1 into D. So here we have A plus 4 minus 1 into D is equal to 19 upon 2. That is A plus 3D is equal to 19 upon 2. Now A is 5, so this implies 5 plus 3D is equal to 19 upon 2. This implies that 3D is equal to 19 upon 2 minus 5, which is equal to 19 minus 10 divided by 2, which is equal to 9 upon 2. This implies that D is equal to 9 upon 2 multiplied by 1 upon 3, and this is equal to 3 upon 2. Therefore, we have D is equal to 3 upon 2. First, we have to find the second term now. It is given by A plus 2 minus 1 into D. A is 5, 2 minus 1 is 1, and D is 3 upon 2. So this is equal to 5 plus 3 upon 2, which is equal to 13 upon 2, and this can be written as 6 then 1 upon 2. Therefore, second term is 6 then 1 upon 2. And also we have to find the third term. Now the third term is given by A plus 3 minus 1 into D. That is 5 plus 2 into D is 3 upon 2. So this is equal to 5 plus, cancelling the common factor from the numerator and denominator, we have 5 plus 3, and this is equal to 8. Therefore, the third term, which is the missing term of the given AP, is 8. Hence, the second term is 6 then 1 upon 2, and the third term is 8. This completes the solution. In the following AP, find the missing term in the boxes. Let's begin with the solution. Let A and D be the first term and the common difference for the given AP. This implies the nth term of the given AP is given by A plus n minus 1 into D. Here we are given the first term and the sixth term. The first term is given to us, which is minus 4, and the sixth term, which is equal to 6. And we have to find the second term, third term, fourth term, and the fifth term. The first term, which is A1, or A is 4. Now substituting the value of A1 in the sixth term, which is given by A plus 6 minus 1 into D, we will get the value of D. This is given to us as 6. This implies minus 4 plus 5t is equal to 6, which further implies 5t is equal to 10, which implies that d is equal to 2. Thus we have a is equal to minus 4 and d is equal to 2. Now let us find the second, third, fourth and fifth term of the given AP. Second term is given by a plus 2 minus 1 into d. A is minus 4 plus 2 minus 1 is 1 into d is 2. This is equal to minus 2. Now let us find the third term. It is given by a plus 3 minus 1 into d. A is minus 4 plus 2 into d is 2. So on simplification this gives 0. Let us now find the fourth term. It is given by a plus 4 minus 1 into d. That is minus 4 plus 3 into d is 2. So this is equal to minus 4 plus 6, which is equal to. And finally let us find the fifth term. It is given by a plus 5 minus 1 into d. That is minus 4 plus 4 into 2. This gives minus 4 plus 8, which is equal to 4. Therefore, second term is minus 2. Third term is 0. Fourth term is 2. And the fifth term of the given AP is 4. This implies the second term is minus 2. Third term is 0. Fourth term is 2. And the fifth term is 4. So, the solution. In the following AP, find the missing term in the box. Let's begin with the solution. And for this AP, let A and D be the first term and the common difference D. This implies that the nth term of the AP is given by A plus n minus 1 into D. In this question we are given the second term, which is 38, and the sixth term, which is equal to minus 22. We have to find the first term, that is A, third term, fourth term, and the fifth term. The second term of the AP can be written as A plus 2 minus 1 into D, which is given to us as 38. This implies A plus D is equal to 38. And also we are given the sixth term. Sixth term is minus 22. This implies A plus 5D is equal to minus 22. Let us denote this by equation 1 and this by equation 2. Now, we will be solving equation 1 and 2 for the values of A and D. Subtracting equation 1 from equation 2, we have A plus 5D minus A plus D on the left hand side, and on the right hand side we have minus 22 minus 38, and this implies this is equal to 4D is equal to minus 60, which further implies D is equal to minus 15. Now substituting the value of D is equal to minus 15 in the first equation, which is A plus D is equal to 38. So we have A plus, the value of D is minus 15, and this is equal to 38. This implies that A is equal to 38 plus 15, and this is equal to 53. Now let us find the third term, It is given by a plus 3 minus 1 into d, that is a plus 2d. Substituting the value of a and d, we have 53 plus 2 into minus 15, which is equal to 53 minus 30, and this is equal to 23. Now let's find the fourth term. This is equal to a plus 4 minus 1 into d, that is a plus 3d. The value of a is 53 plus 3 times of minus 15, which is equal to 53 minus 45, and this is equal to 8. Finally, let us find out the value of the fifth term, which is given by a plus 5 minus 1 into d, that is a plus 4d. Substituting the values, we have 53 plus 4 into d is minus 15. This is equal to 53 minus 60, which is equal to minus 7. Therefore, the first term a is 53, third term is 23, fourth term is 8, and the fifth term is minus 7. So this is the required solution. Let us now fill in the missing terms in the boxes. A is 53, which is the first term. Then we have third term as 23. Then fourth term is 8. And the fifth term is minus 7. This completes the solution. In this question, we have to find 78 is which term of the given AP. Let's begin with the solution. And the given AP is 3, 8, 13, 18, and so on. This implies that the first term, that is denoted by A, is equal to 3. And now let us find the common difference, denoting it by D, which can be found by subtracting any term from its succeeding term, that is 8 minus 3. So this is equal to 5. Now let 78 be the nth term of the given AP. This implies that A plus n minus 1 into D is equal to 78. Now substituting the values of A, that is 3, and D, which is equal to 5 in this equation, this further implies 3 plus n minus 1 into 5 is equal to 78. Now we will solve this equation to get the value of n. This further implies that n minus 1 into 5 is equal to 78 minus 3, that is 75. This further implies that n minus 1 is equal to 75 upon 5, that is 15. This implies n is equal to 16. Therefore, 78 is the 16th term of the given AP. Right? So this completes our solution. In this question, we have to find the number of terms in the given AP. The given AP is 7, 13, 19 and 205. Here the first term of the given AP is 7, right? Let us denote it by A, and this is equal to 7. Now let us find the common difference. Denoting it by D, this can be obtained by subtracting any term from its succeeding term, that is 13 minus 7, or we can also subtract 13 from 19 and so on, and this is equal to 6. Let us suppose that in the given AP there are n terms, right? So the number of terms in the given AP, let us suppose them as n, right? So this implies that the nth term, that is the last term of the given AP, which is 205, right? Now the nth term is given by a plus n minus 1 into d, where a is the first term and d is the common difference. Now substituting the values of a and d. A is equal to 7 and d is equal to 6. This implies 7 plus n minus 1 into 6 is equal to 205. This further implies n minus 1 into 6 is equal to 205 minus 7 is 198. Simplifying it further, we have n minus 1 is equal to 198 divided by 6, and this is equal to 33. This further implies that n is equal to 33 plus 1, that is 34. Therefore, the given AP has 34 terms. This completes the solution. Find the number of terms in the following AP. Here, the given AP is 18, 15 and 1 upon 2, 13 and minus 47. That is 18. This on simplifying gives 31 upon 2, 13 and so on up to minus 47. Now here the first term in this given AP, let us denote it by A, is equal to 18, and let us also find the common difference denoting it by D, which is obtained by subtracting any term from its succeeding term, that is 31 upon 2 minus 18. Taking 2 as LCM, we have 31 minus 36 in the numerator. This gives minus 5 upon 2. Therefore, the common difference is minus 5 upon 2 and the first term is A. Now let, for the given AP, n be the number of terms. This implies the last term, which is minus 47, is the nth term. Now the nth term is given by A plus n minus 1 into d. So this is equal to minus 47. Now substituting the values of A and D in this equation, this further implies A is 18 plus n minus 1 into d is minus 5 upon 2. So this is equal to minus 47. This further implies that n minus 1 into minus 5 upon 2 is equal to minus 47 minus 18, and this is equal to minus 65. This further implies that n minus 1 is equal to minus 65, and on cross multiplying minus 5 upon 2, taking on the right hand side we have minus 2 upon 5. Now 5 into 13 is 65. This implies minus into minus is plus. So 13 twos are 26. This further implies that n is equal to 26 plus 1, and this is equal to 27. Therefore, the given AP has 27 terms, and the 27th term is minus 47. This completes the solution. In this question, we have to check whether minus 150 is a term of the given AP or not. So beginning with the solution, the given AP is 11, 8, 5, 2, and so on. So from this given AP, the first term, denoting it by A, is equal to 11, and the common difference, which is obtained by subtracting any term from its succeeding term, that is 8 minus 11 or 5 minus 8, this is equal to minus 3. Let, if possible, minus 150 be the nth term of the given AP. That is, a nth is equal to minus 150. Now the nth term is given by a plus n minus 1 into d, and this is equal to minus 150. Now we will solve this equation to get the value of n. If n comes out to be a positive integer, this will imply that minus 150 is a term of the AP, otherwise not. Now substituting the values of a and d in this equation, a is 11 plus n minus 1, d is the common difference, denoting it by d, into minus 3 is equal to minus 150. This further implies n minus 1 into minus 3 is equal to minus 150 minus 11, which is equal to minus 161. This further implies that n minus 1 is equal to minus 161 divided by minus 3. This further implies that n is equal to 161 divided by 3 plus 1, which is equal to 164 by 3, and this can further be written as 54 and 2 upon 3. Now, this is not a positive integer. So this implies that minus 150 is not a term of the given AP. So this completes the solution. In this question, we have to find the 31st term of an AP whose 11th term is 38 and 16th term is 73. Beginning with the solution, let A and D be the first term and the common difference of the given AP, whose 11th term is 38 and 16th term is 73. This implies that A plus 11 minus 1 into D is equal to 38. Let us denote this by equation 1, and 16th term is 73 implies A plus 16 minus 1 into D is equal to 73. Let us denote this by equation 2. Now, from equation 1 and equation 2, we have A plus 10D is equal to 38 and A plus 15D is equal to 73. Now, on subtracting the second equation from the first one, we have minus 5D on the left hand side and minus 35 on the right hand side. This further implies that D is equal to minus 35 divided by minus 5, and this on simplifying comes equal to 7. This implies that D is equal to 7. Now, substituting D is equal to 7 and A plus 10D is equal to 38 to get the value of A. This implies A plus 10 into 7 is equal to 38. This further implies A is equal to 38 minus 70, and this is equal to minus 32. Therefore, we have A is equal to minus 32 and D is equal to 7. We have to find the 31st term, that is A31, and this is given by A plus 31 minus 1 into D. Substituting the values of A and D, we have A is minus 32 plus 30 into 7. This is equal to minus 32 plus 210, which on simplifying comes equal to 178. Therefore, the 31st term, whose 11th term is 38 and 16th term is 73, is 178. This completes the solution. In this question, we have an AP which consists of 50 terms, of which the third term is 12 and the last term is 106. We have to find the 29th term. Let's begin with the solution. For the given AP, let A and D be the first term and the common difference whose third term and the last term is given, that is A3 is equal to 12, and since there are 50 terms, therefore the 50th term, which is the last term, 106, is Now, third term of AP is 12 implies A plus 3 minus 1 into D is equal to 12. This implies A plus 2D is equal to 12, denoting this by equation 1, and 50th term is 106 implies A plus 50 minus 1 into D is equal to 106. This implies A plus 49D is equal to 106. Let us denote this by equation 2. Now, subtracting equation 1 from 2, we have A plus 49D is equal to 106. We have to subtract A plus 2D is equal to 12 from this. This implies 47D is equal to 94. This implies D is equal to 94 upon 47, which on simplifying gives D is equal to 2. Now substituting the value of D in equation 1, which is A plus 2D is equal to 12. This implies A plus 2 into 2 is equal to 12, which further implies A is equal to 12 minus 4, which is equal to 8. This implies that A is equal to 8 and D is equal to 2. Now we have to find the 29th term, and the 29th term of the given AP is equal to A plus 29 minus 1 into D. Substituting the value of A and D, we have 8 plus 28 into 2. This gives 8 plus 56, which is equal to 64. Therefore, the 29th term of the given AP is equal to 64. This completes the solution. This question says, if the third and ninth terms of an AP are 4 and minus 8 respectively, which term of this AP is 0? First, let us suppose one AP having terms A1, A2, A3, A4 and so on. Here we are given that the third term of this AP is equal to 4 and the ninth term is equal to minus 8. And we have to find the nth term such that it is equal to 0. Now, nth term of an AP is given by A plus n minus 1 into D, where A is the first term and here A is equal to A1 and D is the common difference. Therefore, the third term of this AP is given by A1 plus 3 minus 1 into D, and the ninth term is given by A1 plus 9 minus 1 into D. This further implies that third term of an AP is A1 plus 2D and the ninth term of the AP is A1 plus 8D. Let us denote this by equation 1 and equation 2. Now the third term of the AP is 4. So 4 is equal to A1 plus 2D. And the ninth term is minus 8. So we have minus 8 is equal to A1 plus 8D. Let us denote these equations by 3 and 4. Now, subtracting equation 4 from 3, we have on subtracting, A1 cancels out with minus A1. On the left hand side we have 12 and on the right hand side we have minus 6D. So this implies D is equal to minus 2. Now substituting the value of D is equal to minus 2 in equation 3, this further implies 4 is equal to A1 plus 2 into D and the value of D is minus 2. This further implies 4 is equal to A1 minus 4, which implies that A1 is equal to 8. So the first term of the given AP is 8 and the common difference is minus 2. We have to find which term of this AP is 0. So let nth term of the given AP be 0. This implies An is equal to 0. This further implies A1 plus n minus 1 into D is equal to 0. Now substituting the value of A1 and D, A1 is 8 plus n minus 1 into D is minus 2 is equal to 0. Now we will simplify this equation to get the value of n. This further implies that n minus 1 into minus 2 is equal to minus 8, which further implies that n minus 1 is equal to minus 8 upon minus 2, and this is equal to 4. So this implies n is equal to 4 plus 1, which is equal to 5. Hence, fifth term of the given AP is 0. This completes the solution. This question says that the 17th term of an AP exceeds its 10th term by 7. We have to find the common difference. First, let us suppose the given AP has terms A1, A2, A3, A4 and so on. Here we are given that the 17th term exceeds its 10th term by 7. This implies that the 17th term is greater than the 10th term by 7, or we can say that 17th term is equal to the 10th term plus 7. Now we know that the nth term of an AP is given by A1 plus n minus 1 into D, where A1 is the first term and D is the common difference. Therefore, this can further be written as A17 can be written as A1 plus 17 minus 1 into D is equal to A1 plus 10 minus 1 into D plus 7. where D is the common difference and A1 is the first term. Simplifying it further, A1 cancels out with A1. We have on the left hand side 16D is equal to 9D plus 7, which further implies 16D minus 9D is equal to 7, which implies that 7D is equal to 7, or D is equal to 1. Hence, the common difference is equal to 1. This completes the solution. In this question, we are given one AP with terms 3, 15, 27 and 39, and we have to find which term will be 132 more than the 54th term. Let's begin with the solution. The given AP is 3, 15, 27, 39 and so on. For this AP, the first term is 3. Let us denote it by A, and the common difference, which is obtained by subtracting any term from its succeeding term, that is 15 minus 3 is equal to 12. Let us denote it by D. We have to find the nth term of the given AP such that the nth term is equal to the 54th term plus 132. Now we know that the nth term of an AP is given by A plus n minus 1 into D, where A is the first term and D is the common difference. Therefore, this can further be written as A plus n minus 1 into D is equal to A plus 54 minus 1 into D plus 132. This further implies cancelling A with A. On the left hand side we have n minus 1 into the value of D is 12. So substituting the value of D, on the right hand side we have 53 into 12 plus 132. This further implies n minus 1 into 12 is equal to 636 plus 132, which is further equal to 768. This further implies that n minus 1 is equal to 768 divided by 12, which is equal to 64. This implies that n is equal to 64 plus 1 is equal to 65. Hence, 65th term of the given AP will be 132 more than the 54th term. So this completes the solution. In this question, we are given two APs with the same common difference. The difference between their 100th terms is 100. What is the difference between their 1000th term? Let's begin with the solution and let the terms of the two AP be A1, A2, A3, A4 and B1, B2, B3, B4 and so on be the two given APs such that they have the same common difference D. We are given that the difference between their 100 terms is equal to 100. That is, the 100th term of the first AP minus the 100th term of the second AP is equal to 100. Now we know that nth term of an AP is given by A1 plus n minus 1 into D, where A1 is the first term, and the nth term of the second AP is given by B1 plus n minus 1 into D, where B1 is the first term. Therefore, this can further be written as A1 plus 100 minus 1 into D minus of B1 plus 100 minus 1 into D is equal to 100. This further implies A1 plus 99D minus B1 minus 99D is equal to 100. This further implies 99D cancels out with minus 99D. We have A1 minus B1 is equal to 100. We have to find the difference between their 1000th term, that is, 1000th term of the first AP minus the 1000th term of the second AP we have to find out. Now, let us find the value of the left hand side. That is, 1000th term of the first AP minus the 1000th term of the second AP. Now, the 1000th term of the first AP is given by A1 plus 1000 minus 1 into D, and the 1000th term of the second AP is given by B1 plus 1000 minus 1 into D. This is further equal to A1 plus 999D minus B1 minus 999D. So plus 999D cancels out with minus 999D. This is equal to A1 minus B1, and the value of A1 minus B1 is 100. Therefore, this is equal to 100. Hence, the difference between the 1000th term is 100. So, this completes the solution. This question says, how many three-digit numbers are divisible by 7? Let's begin with the solution. And we know that the smallest three-digit number is 100, and the largest three-digit number is 999, and the three-digit numbers divisible by 7, which lie between 100 and 999 are, the first number is 105, then we have 112, then 119, 126, and the last number which is divisible by 7 and which is less than 999, since 999 is not divisible by 7, is 994. Now, this list of number is clearly an AP since the difference between any term and its succeeding term is 7. Thus, the list of numbers is an AP with first term denoting it by A, 105 and common difference denoting it by D is 7. Now let 994 be the nth term divisible by 7. This implies that nth term of the list of numbers is 994. Now since the nth term is equal to A plus n minus 1 into D, where A is the first term and D is the common difference, therefore here the nth term can be written as A plus n minus 1 into D, and this is equal to 994. This further implies, now let's substitute the value of A and D. A is 105 plus n minus 1 into D is 7 is equal to 994. This further implies n minus 1 into 7 is equal to 994 minus 105, and this is equal to 889. This further implies that n minus 1 is equal to 889 divided by 7, and this on simplifying comes equal to 127. This implies that n is equal to 127 plus 1, which is equal to 120. Hence, there are 128 three-digit numbers that are divisible by 7. This completes the solution. This question says, how many multiples of 4 lie between 10 and 250? Let's begin with the solution. The multiples of 4 that lie between 10 and 250 are 12, 16, 20, 24, and the last multiple is 248. This list of number forms an AP since the difference between any term and its succeeding term is 4. Right? Since 16 minus 12 is 4, 20 minus 16 is 4 and 24 minus 20 is 4. Therefore, this is an AP. The list of numbers is an AP and its first term is, denoting it by A, is 12. Since 12 is the first number which lies between 10 and 250, which is a multiple of 4, and the common difference that is denoted by D is obtained by subtracting any term from its succeeding term, and that comes out to be 4. Therefore, common difference is 4. Here the last term, which is a multiple of 4 between 10 and 250, is 248. Therefore, the nth term, which is a multiple of 4 between 10 and 250, is 248. Therefore, we have nth term of the given list of number is 248, and we know that the nth term of an AP is given by A plus n minus 1 into D, where A is the first term and D is the common difference. Therefore, here we can write it as A plus n minus 1 into D is equal to 248. Now, substituting the value of A and D, A is equal to 12 plus n minus 1 and D is 4 is equal to 248. This further implies that n minus 1 into 4 is equal to 248 minus 12. This implies that n minus 1 into 4 is equal to 236. This implies n minus 1 is equal to 236 divided by 4, which gives 59. This implies that n is equal to 59 plus 1, which is equal to 60. Hence, 60 multiples of 4 lie between 10 and 250. Since the last term is 248, which is the 60th term. This completes the solution. This question says, for what value of n are the nth terms of the two APs equal? Let's begin with the solution. And here we are given two APs. The first AP has terms 63, 65, 67, and so on. And the second AP has terms 3, 10, 17, and so on. Now first let us find the first term and the common difference of the first AP. First term, here as we can see, is 63. Let us denote it by small a, and common difference, denoting it by small d, is obtained by subtracting any term from its succeeding term, and the difference here is 2, since 65 minus 63 is equal to 2. And now let us find the first term and the common difference for the second AP. The first term for the second AP is 3, denoting it by small b, and the common difference denoting it by p. This is given by, again, on subtracting any term from its succeeding term, that is 10 minus 3 is equal to 7. Now let us suppose that the nth terms of the first and the second AP, which are given to us, are equal. This implies that the nth term of the first AP is equal to the nth term of the second AP, where this denotes the nth term of the first AP, and this denotes the nth term of the second AP. This further implies that nth term of the first AP is given by A plus n minus 1 into D, and the nth term of the second AP is given by B plus n minus 1 into P. Now let us substitute the value of A, D, B and P. And this implies the value of A is 63 plus n minus 1 into D is 2 is equal to the value of B is 3 plus n minus 1 into the value of P is 7. This further implies that n minus 1 into T, taking n minus 1 into 7 on the left hand side and 63 on the right hand side, we have 3 minus 63 on the right hand side. This implies, now taking n minus 1 common, we have n minus 1 into 2 minus 7, and this is equal to minus 60, which further implies that n minus 1 is equal to minus 60 divided by minus 5. On simplifying 2 minus 7, we get minus 5. This implies that n minus 1 is equal to 12. Since on simplifying, we get this equal to 12. This implies that n is equal to 13. Thus, the value of n is 13. Hence, we can say that 13th term of the two given APs is equal. This completes the solution. This question says, determine the AP whose third term is 16 and seventh term exceeds the fifth term by 12. Let's begin with the solution. And let A1, A2, A3, A4 and so on be the required AP. With common difference D. We are given that the third term of the AP is 16 and the seventh term exceeds the fifth term by 12. This implies that seventh term is the sum of the fifth term and 12. Now the third term is 16. This implies that A1 plus 3 minus 1 into D is equal to 16, which further implies that A1 plus 2D is equal to 16, and let us denote this by equation 1. Also, let us now simplify this equation. It says that the seventh term, which is A1 plus 7 minus 1 into D, is equal to the fifth term plus 12. Fifth term is A1 plus 5 minus 1 into D plus 12. Cancelling A1 with A1. On the left hand side we have 6D. Here we have 4D. Taking it on the left hand side we have minus 4D is equal to 12. This further implies that 2D is equal to 12 or D is equal to 6. Now substituting the value of D in equation 1 to get the value of A1, which is the first term, we have A1 plus 2 into D is equal to 16, which implies A1 plus 2 into 6 is equal to 16. This implies that A1 is equal to 16 minus 12, which is equal to 4. Therefore, the first term is 4. Now, we know that in an AP, every succeeding term can be obtained by adding the common difference D to the preceding term. Therefore, the second term can be obtained by adding the common difference to the first term, that is A1 plus the common difference D. The value of A1 is 4 and the common difference is 6, so this is equal to 10. The third term can be obtained by adding the common difference D to the second term, that is 10 plus 6, which is equal to 16. And the fourth term can be obtained by adding the common difference D to the third term, that is 16 plus 6. This gives 22, and so on. Hence, the required AP is, the first term is 4, second term is 10, then we have 16, then 22, and so on. This completes the solution. This question says, find the 20th term from the last term of the given AP. Beginning with the solution, the given AP is 3, 8, 13, and so on, and the last term is 253. We have to find the 20th term from the last term. On reversing the given AP, the last term becomes the first term, and similarly we have 13, 8, and the first term will become the last term. Now on reversing the AP, this implies that we have to find the 20th term of this AP. For this AP, the first term, denoting it by small a, is equal to 253, and the common difference, denoting it by small d, is given by 8 minus 13, which is equal to minus 5, since common difference is obtained by subtracting any term from its succeeding term. Therefore, we have 8 minus 13 or 3 minus 8, which is equal to minus 5. We have to find the 20th term, and this is given by a plus 20 minus 1 into d, since the nth term of an AP with the first term a and common difference d is given by a plus n minus 1 into d. This is further equal to substituting the value of a, which is 253, plus 19 into d is minus 5. This is further equal to 253, plus into minus is minus, and 19 into 5 is 95. This is further equal to 158. Hence, the 20th term from the last term of the given AP 3, 8, 13 and so on up to 253 is 158. So this completes the solution. This question says that the sum of the 4th and the 8th term of an AP is 24 and the sum of the 6th term and the 10th term is 44. Find the first 3 terms of the AP. First, let us suppose that A1, A2 and A3 be the first 3 terms of the required AP. With common difference D. We are given that the sum of the 4th term and the 8th term is equal to 24 and the sum of the 6th term and the 10th term is equal to 44. Now, from these two equations, we will find the value of the first term and the common difference, and then we will find the first 3 terms of the AP. Let's begin with the first one. It says that the sum of the 4th term and the 8th term is equal to 24. This implies that A1 plus 4 minus 1 into D plus A1 plus 8 minus 1 into D is equal to 24, since the nth term of an AP is given by A1 plus n minus 1 into D, where A1 is the first term and D is the common difference. So this further implies that 2 times of A1 plus 3D plus 7D is equal to 24, which further implies that 2A1 plus 10D is equal to 24. Now dividing both the sides by 2, this gives A1 plus 5D is equal to 12. Let us denote this by equation 1. Also, we are given that the sum of the 6th term and the 10th term is equal to 44. This implies A1 plus 6 minus 1 into D plus A1 plus 10 minus 1 into D is equal to 44. This further implies that 2 times of A1 plus 5D plus 9D is equal to 44. This further implies that 2 times of A1 plus 9D plus 5D gives 14D is equal to 44. This further implies that A1 plus 7D is equal to 22, which we get on dividing both sides of this equation by 2. Let this equation be 2. Now, subtracting equation number 2 from 1, on the left hand side we have A1 plus 5D minus of A1 plus 7D, and on the right hand side we have 12 minus 22. This further implies that A1 plus 5D minus A1 minus 7D is equal to minus 10. This further implies that A1 cancels out with minus A1, and here we have minus 2D is equal to minus 10, which further implies that D is equal to minus 10 upon minus 2, which is equal to 5. This implies that D is equal to 5. Now, substituting the value of D is equal to 5 in equation 1 or in equation 2 to get the value of A1, let us put it in equation 1, which is A1 plus 5D is equal to 12. The value of D is 5. This is equal to 12. This implies that A1 is equal to 12 minus 25, which is equal to minus 13. This implies that A1 is equal to minus 13. Now we have to find the second term, and the second term can be obtained by adding the common difference D to the first term, since every term of an AP can be obtained by adding the common difference D to the preceding term. Therefore, here we have minus 13 plus 5, which is equal to minus 8. Similarly, the third term can be obtained by adding the common difference to the second term. Second term is minus 8 and common difference is 5, so this is equal to minus 3, and hence the first three terms of the given AP are minus 13, minus 8 and minus 3. This completes the solution. This question says, Subba Rao started work in 1995 at an annual salary of rupees 5,000 and received an increment of rupees 200 each year, in which year did his income reach to rupees 7,000. Let's begin with the solution. We are given Subba Rao's first salary is equal to rupees 5,000 and he received an increment of rupees 200 each year. This implies that Subba Rao's second salary is equal to rupees 5,000 plus 200, and this is equal to rupees 5,200. Similarly, we can calculate Super Rao's third year salary, and this is equal to rupees 5,200 plus rupees 200, and this is equal to rupees 5,400. Thus, Super Rao's salary for the consecutive years is given by 5,000, 5,200 for the second salary. His third salary is 5,400, and so on. And we have to find in which year did his income reach to rupees 7,000. Now this list of numbers is an AP, since the common difference between two consecutive salaries is rupees 200, since he received an increment of rupees 200 each year. Therefore, the given list of numbers is an AP with first term, denoting it by A, equal to 5,000, and the common difference, which can be obtained by subtracting any term from its succeeding term, denoting it by small d, equal to 200. We have to find the nth year in which his income reached to rupees 7,000. That is, we have to find the value of n such that an is equal to 7,000. Now, we know that the nth term of an AP is given by a plus n minus 1 into d. Therefore, this can further be written as a plus n minus 1 into d is equal to 7,000. Now, substituting the values of a and d, a is 5,000, plus n minus 1 into d, which is the common difference, is 200. So this is equal to 7,000. This further implies that n minus 1 into 200 is equal to 7,000 minus 5,000, which is equal to 2,000. This further implies that n minus 1 is equal to 2,000 divided by 200, which implies that n is equal to 10 plus 1, which is equal to 11. Hence, Super Rao's income will reach to rupees 7,000 in the 11th year. So, this completes the solution. This question says that Ramkali saved rupees 5 in the first week of a year and then increased her weekly saving by rupees 1.75. If in the nth week her weekly savings become rupees 20.75. Find n. Let's begin with the solution. Ramkali's first saving is equal to rupees 5. Now she increased her saving by rupees 1.75. Therefore, Ramkali's savings for the second week is equal to rupees 5 plus 1.75, and this is equal to rupees 6.75. Similarly, we can find Ramkali's saving for the third week. This is equal to rupees 6.75 plus 1.75, and this is equal to rupees 8.50. Thus, Ramkali's saving for the consecutive weeks is given by first week her saving is 5, then 6.75 in the second week, and the third week her saving is 8.50. Now clearly this forms AP. With the first term denoting it by A equal to 5. This is the first term, and the common difference denoting it by small d equals to 1.75, since the difference in the consecutive week saving is 1.75. Also, we are given that Ramkali's saving in the nth week is equal to rupees 20.75, and we have to find the value of n. That is, a nth term is 20.75. This further implies a plus n minus 1 into d is equal to 20.75. Now substituting the value of a and d, this can further be written as 5 plus n minus 1 into 1.75 is equal to 20.75. This further implies that n minus 1 into 1.75 is equal to 20.75 minus 5. This implies n minus 1 into 1.75 is equal to 15.75. This further implies that n minus 1 is equal to 15.75 divided by 1.75. 5. And this on simplifying comes equal to 9. This implies n is equal to 9 plus 1, which is equal to 10. Thus, we can say that Ramkali's savings becomes rupees 20.75 in the 10th week. So this completes our solution.